Hello students, in this video I will go through the process of finding the points of intersection between two lines. When we are finding a point of intersection between two lines, there are three primary methods for going about this. We can either solve this, two of which are going to be more of an algebraic approach, and the third method will be more of a geometric or graphical approach. So the first one being its substitution, where we try to substitute represent one variable in terms of another, and then directly substituting that into the second equation. The second method is, again, algebraic, and it will take the form of, or commonly referred to as, the elimination method. The elimination method, what we try to do is eliminate one of the variables and then successively try to solve for the remaining variable. Being that whenever we're writing the equation of a line, there is often two variables being used, and the only exceptions are when we're representing a horizontal line versus a vertical line. Anytime that the slope is defined, we have to represent the equation of a line using two variables. So the third method is graphical, where we try to graph out both equations and try to identify where the points of intersection take place. In this video, we are going to try to solve for the points of intersection algebraically first, and then I will demonstrate how the algebraic solution must always be consistent with the graphical solution. So I have two equations here, two lines represented by y equal to 2x plus 3 and y is equal to negative half x minus 7. So we're going to try to solve for this, the points of intersection, which means we're going to look for a coordinate x and coordinate y. So being that the y coordinates are, the y variables are already isolated, I will directly just substitute one in for the other, which is what I did here. I took the top equation and directly substituted it in for the second equation. So I end up with 2x plus 3 is equal to negative half x minus 7. Again, the action was I took this and directly substituted it in for that. And this is just a matter of bringing all the variables to one side and isolating the unknown. I will now subtract 3 from both sides, leaving me with 2x is equal to negative half x minus 10. And I will add half x to both sides, leaving me with 5 halves x is equal to negative 10. I will then multiply both sides by the reciprocal of that fraction, so multiply both sides by 2/5. I end up with x is equal to negative 4. And taking x is equal to negative 4, I will then substitute it into either the first equation or the second equation to determine what y is. So by placing it into the first equation there, I end up with y is equal to negative 5. So the coordinate, the point of intersection, is negative 4 comma negative 5. I will now try to solve for the point of intersection graphically. And again, if you did the graphical approach first, you should have arrived at the same conclusion, that it should also be negative 4 comma negative 5. So to graph out 2x plus 3, I will pinpoint the y-intercept, which is 3, and a slope of 2, which is going to look like this. Whoops. And by placing all the, and do the same thing with the bottom equation, which is negative 7, count down 7, and then apply the slope of negative half. I end up with, again, the point of intersection over here, which is negative 4 comma negative 5.